Hello and welcome back to another lesson of the TI-84 plus CE student course. In this lesson we're looking at matrices, and this is part of the optional learning section of the course. In this lesson we're going to look at inputting a matrix into your TI-84 plus CE, some operations using matrices, finding the inverse of a matrix, matrix maths functions, and we're going to do quite a lot of solving equations as well. So the very first example we're going to look at, we've got a matrix A, and we've classified that as 4, -6, -2, 8. So the very first thing we're going to do is chuck that equation into our calculator. Alright, so here we are. I'm going to head into my matrix menu, which is the second function of that inverse key with the x to the power of -1 just on that left-hand side. So if I go second and press that button here, we'll see our matrices come up there. So this is the names of all of our matrices that we can have. The next one, if we tab across using those navigation keys, we get into the matrix maths menu. If we tab across one more, this is how we actually input a matrix. So it's under that edit heading. So I'm just going to input my matrix under A. So if I press enter, and it comes up, and first we've got to do is input how many rows and columns we want. So my matrix was a square 2 by 2 matrix, so I'm just going to change that to 2, and my number of columns to 2. Okay, so in here we can put in the numbers. So the first thing I had was 4 in that first position, then -6, then I had -2 and 8. Okay, so there's my matrix A. Now the very first thing my question wanted was me to find what's 2A. So really nice and easy. Back in my main screen, I'm going to press 2, and then I'm going to multiply that by my matrix A. And just keep in mind, you don't need to put in a multiplication sign there. If you just have 2A and press enter, that will come up on the screen there. Alright, so that's 2 times A. The next one we need to do is A squared. So again, I'm going to head back into that matrix menu, bring down matrix A into my main screen, and then I can just use my square button, same as I would if I was squaring any number, and there's my solution. Now I just wanted to head back into my PowerPoint quickly here, just so I could talk about the next question. So if you're not familiar with matrix multiplication, hopefully you are, this might be a little bit confusing. So we want to find B, where we've got A times by B is equal to 5, 0. So we have a solution matrix there, and we're wanting to solve what would our matrix B be. So I've put up here a little bit of matrix algebra on the side. So that's how we're going to kind of work it out. If you need to, you can pause the video and have a look at that, but pretty much we're just going to pre-multiply by our, pre-multiply by our inverse of matrix A, and we're going to multiply that by our solution matrix, which I'm calling there C, just for convenience. Alright, well how does this look on the calculator? So it looks a little bit like this. We're going to go back into that matrix menu. We're going to cruise across back to edit, and just so I keep all the letters the same, this time I'm going to edit my matrix C. So it's a 2 by 1 solution matrix, 2 rows, 1 column. We're going to have 5 in that top spot, and it was 0 in that second spot. So that's my solutions. So like I said, now what I'm going to do is I'm going to find the inverse of my matrix A. So again, second matrix, I'm going to select A. I'm going to take the inverse of that. So I can just use that using that -1 key, same one as we used to get into the matrix menu. Press enter, and there we go. That's my inverse of A. I can then multiply that inverse of A by my solution matrix, matrix C. And there we go. That's my answer. So that must be what my matrix B must be in order to get C as the answer. What I'm going to do is I'm going to store that, just so I can double check my answer. I'm going to store that under second matrix. I'm going to store that under matrix B, and then I can just check to see whether I've done the right thing. And I'd highly recommend it. Matrix algebra is very dependent on the order of operations and the order of the matrices. So it's always, I think, a super handy thing if you're doing any calculations with matrices to go back and double check your answer. So if I store my answer there, I can then go through and multiply A with matrix B, And there we go, I get matrix C as my answer. And just in case you'd forgotten what matrix C was, I can chuck that on the screen there so we can see that those are exactly the same. So therefore I must have the correct solution. Alright, staying with our same theme of solving equations here, we've got another system of equations. We're going to solve for x, y, and z. And we've got our matrix A here, which is a 3 by 3, and then we've got a solution matrix B. I'm just going to go through with you a slightly different way that we can solve for x, y, and z. That's using an augmented matrix. And what that's going to look like, hang on, I'll just grab my calculator up. Alrighty, so instead of having a matrix now, which is just going to be like a 3 by 3 matrix, and then using another matrix with the solutions, we're going to put the initial matrix and the solutions all together and make what we call an augmented matrix. So if I head into my matrix menu again, I'm going to go across and edit. Now I'm going to edit A again, just keep things nice and easy. And in this case, instead of having a 2 by 2 matrix, we're having a 3 by 4 matrix. So that's our 3 by 3 matrix, and also the solutions on the end there. So I'm just going to input those numbers. Okay, so here's the final product. So we can see here this first kind of 3 by 3 part here, that's that matrix A that we had before. I'll just quickly flip back and show you. Okay, and then that last column is our solution. So to solve for our variables, we would then quit out of this again, take us back to the main screen. I'm going to go back into the matrix menu again though, and now I'm going to go to the maths section. And I'm going to scroll again, either up or down using your navigation keys until you get to this RF, and that stands for reduced row echelon form. And what that's going to do is it's going to solve for each of those variables. So we're going to press enter. Well, then we're going to input our matrix A, press enter again, and there we go. So this, the identity matrix, that first 3 by 3 part, we can ignore that, and our solutions would be x is 2, y is 4, and z is -3. Last little bit I've got in here is another way to solve an equation, and I've put this in here because it's not often covered at school, but I think it's a really lovely way of solving the equations, and again something that can come up quite nicely on your 84. It does involve a little bit of inputting first, so I'm just going to do that, and then I'm going to show you the result. Okay, so Cramer's rule is just involves making 4 matrices. The first one I'll show you here, A, this is just our standard coefficient matrix. But if we look at B, if I just go across into here, B, we've replaced the first column in B, that's our X column, with our solutions like we had before. And we do the same thing for matrix C and matrix D, except for matrix C we replace the Y variable column, and for matrix D we replace the Z variable column. I'll just show you those two as well so you can have a quick look. So there's C, again the solutions are in the middle now, and then with matrix D, again the solutions are now in our final column. So what we do is we're going to find the determinant of each of those 4 matrices, and we can find the determinant really nice and easily using our maths menu there, and it's the very first one that comes up. So the determinant, so the first one we're going to find is the determinant of A. There you go, -54, and that's, remember, that's our coefficient matrix. The next one we're going to find the determinant of is matrix B, which is that one that had the X variables replaced with the solutions. Okay, so there's the determinant of B. The next one we're going to find is our, talking and flipping around here a little bit, so just be careful. So then we're going to find C, that was our Y one. And then we're going to do our last one, so with our Z, so determinant of matrix D. Okay, so there we go. So now what we can do is we can go through and divide each of those, B, C, and D, by our original determinant A, and that will tell us our variables X, Y, and Z. So our variable X would be -270 divided by -54, so 5. Our Y variable would be -54 divided by -54, we all know what that's going to be, 1. and our z variable is going to be 108 divided by negative 54, and there we go, negative 2. So x 5, y 1, z negative 2. A couple of other things we'll just quickly talk about that we can do using our matrix maths menu really quickly is I really like this cumulative sum. And what I find this is really handy for if you're doing, say, something like a Leslie matrix where you've got a population or really big variables. I'll just show you using my matrix A from before. What the cumulative sum does is it adds together everything in a column so that your last value in the column is your cumulative sum of everything before it. So if we can see here, this was our A. So the sum of our first column is 7. The sum of our second column is negative 3. And the sum of our third column is 1. So that can be a really, really handy tool to use as well. Alrighty, well I think that's it from me for today, and I'll see you guys next time.